Hello guys, this is Farhan from AlgosFromScratch, and I welcome all of you to this amazing YouTube playlist on building DistilBERT model from scratch using PyTorch. This is going to be the 5th video of this playlist, and I am going to start this video with 4 questions philosophy. So starting with, what layers and sub layers does it contain? This is the question that answers the architectural understanding of the model. With this, we understand what modules and submodules, like what classes and subclasses do we have in our model architecture. Okay, then once we understand the architecture, we can then switch to the next part, that is understanding the parameters names and their shapes. So what kind of parameters initialized and what kind of shapes these arguments have, we are going to explore them. Okay, then we have this, how is it actually computed? Okay, so once we understand the architecture, the actual values and their shapes, then definitely we need to understand in which order they get executed, so to perform the computations in the model architecture. Okay, and finally, while computing these values, we will see different kind of hyperparameter values. So we will try to understand where these values come from in the architecture. Okay, so starting with the model architecture. Okay, so this is the notebook that we have been using, and this is where I fine-tuned the model and then explored the tokenizer. So here I will start with the print model. Let me just print the model. This is what I get. Okay, and let me copy the output and paste it over here. This is the overall architecture. Okay, now when print the model, each and every module that is registered with the help of nn.module, we get all those registered modules and submodules on our screen. Okay, so this nn.module already has this default underscore repr which basically registers everything inside the constructor that starts with maybe the self dot anything. Okay, so it will register all those constructor level arguments, and then we can see them with the help of this model. Okay, and in this, if you look into this first class, here we can see the first class is DistilBERT for sequence classification. It starts and end here, and it basically wraps everything inside it. Okay, and if we look into its constructor level arguments, we can see DistilBERT is basically a class. Okay, so this DistilBERT, like self.DistilBERT, will have this DistilBERT model. Okay, and then we have these pre-classifier, classifier, and dropout constructor level arguments. These are nothing but simply the leaf nodes, you can say, the linear and dropout layers. Okay, so this call basically is a recursive call. It keeps calling till the leaf nodes, like the linear, and embeddings. So this is how we get this structure, this architecture. Okay, now if you just look into this first one, and then inside this, the DistilBERT, so DistilBERT is again starting from here, and if you look into the ending parentheses, it ends here. Okay, and it wraps everything above it, like above the pre-classifier, classifier, and dropout. It wraps everything in it. Okay, and within this we have these two constructor level arguments. You can see embeddings. It will be something like self.embeddings, self.transformer, and both of these constructor level arguments are initializing the embeddings and transformer classes. Okay, so this first one, embeddings, is straightforward. It gets to the leaf node, like this embedding, and layer norm, dropouts. So it is pretty much clear. Then we have this block. It is basically a transformer class, and we if we look into the transformer class, it starts from here and ends here, and everything it basically wraps in it. And the only argument, the constructor level argument, is this self dot layer, and it basically is the module list. Module list, you can say, is the container. It, you can compare it with the list of Python, and it basically combines or collects all the blocks, but it is more compatible with the PyTorch code. So for the tasks specific to the PyTorch, like getting registered with the PyTorch, moving to the device, so all these kind of tasks are pretty much comfortable with this module list, so rather than the plain Python list. Okay, so inside this module list, basically we have these 6 transformer block classes. Okay, so this transformer block class starts from here and ends here. We have 6 of these classes, and inside this transformer block class, if you see, we have 4 arguments. So the first one is attention. It will be like something self dot attention, self dot linear SA layer norm, self dot FFN, that is a feed forward neural network, and self dot output layer norm. Please try to understand, this is where we are actually trying to understand the architecture. Okay, so we can later on build it from scratch. If we do not understand this, we will not be able to build it from scratch. So within this attention, now you can see we again have this DistilBERT self attention class, and this has now these constructor level parameters. Okay, so Q linear, K linear, then V linear. So this is the leaf node. Then we do not have any child class of this DistilBERT self attention class. This is the straight layer norm, and this is the feed forward class. Okay, so this is again a feed forward class, and it is again the leaf node. Okay, so we do not have any further internal classes within them. And final one is this output layer norm. Okay, so we have all these classes. First of all, this DistilBERT for sequence classification, then this one, the DistilBERT model. We also have the embeddings class, and we have this transformer class. Within this we have the transformer block and DistilBERT self attention, then feed forward neural network. Okay, so we have all of these classes. Okay, and these classes perform the different kind of computations. And if I give you an overview of this, so you can say it is something like we have this DistilBERT classification, the outermost class, and inside this DistilBERT for sequence classification class, we have this first block, that is the DistilBERT. Okay, starting from here till this point. Okay, and then these 3. So if we just draw them, so these are the pre-classifier, classifier, and then the dropout. This is the block that basically contains everything above. Okay, so it first of all contains the embedding layer and then the transformer block. Okay, and so we can see here is the embedding layer, embeddings layer, and then we have this transformer block. We have then this transformer block. Okay, inside this transformer block I have 6 blocks of this, you can say, this transformer block class. Okay, so I will be just making maybe them with the abstraction. Okay, so this is the abstraction. You can consider 8, like it starts from 0 till 5. And now if you look into the in one transformer block, it contains the DistilBERT self attention class and feed forward, okay, and these layer normalization and adding layers. Okay, so it is add and normalize. Now if I just open this one black block, so I can draw it right here, and inside this it contains the DistilBERT self attention class. So here we have DistilBERT self attention class, and then we have the SA layer norm, okay, SA layer norm, and then we have this feed forward neural network. Okay, so feed forward neural network. Okay, and then we have the output layer norm. So output layer norm. Okay, and this basically the green block, we have this green block inside this. Okay, so like this one block, basically this one black box is nothing but this 4 steps. So we have the constructor level arguments, like this DBSA stands for DistilBERT self attention. Then we have another constructor level argument, that is SA layer normalization. Then we have feed forward network, and then we have the last constructor level argument, that is out LN, that is output layer normalization. Okay, so with this now we understand the architecture of the model. Okay, we know how we can create this architecture now. Okay, so this will be the outermost class. Okay, this DistilBERT for sequence classification. Inside this, when we enter, we will see the DistilBERT model. Okay, and inside this DistilBERT model, we will first of all see the embedding layer. Inside this embedding layer, we will enter the transformer, and inside this transformer we will then see 6 transformer blocks. Okay, so each transformer block is this. Okay, and inside each transformer block we will have these 4 steps. Okay, and once we are out of this transformer block that starts from here and till this point, okay, so it then will give us the output of this will enter again to the transformer block, and 6 times it will repeat, and then it will pass the answer to the pre-classifier. So after this let me see, so after this DistilBERT model, that one, yeah, just closing before the pre-classifier. Okay, so it then passes the output to the pre-classifier, then classifier, then the dropout. So don't worry, this is not the sequence, basically it is executing, and that is why we are moving now to the next part, where we will be looking into the actual parameters name, and then we will also see how in which sequence they are called. Okay, so this is the overall architecture. Now if we go to the second question, that is, what are the exact parameter names and shapes? So the exact parameter names and shapes, if I want to find them, exact parameter and names and shapes, basically we have this model dot state dict. This model dot state dict basically returns all the learnable and the buffer values with their names and their you can say the shapes complete. Okay, so it registers everything first, all the trainable and the buffer values, and then if you call it, it gives you an ordered dictionary. Okay, so if I print it, you can see it's a large dictionary. Okay, takes time. Okay, so this is the dictionary. If I just print the type, okay, and here you can see it's the collection ordered dict. Okay, so basically here we get the parameter names and their values. Okay, all the tensors. And if I just call this items on it, and let me now loop over it, okay, for let's say name and value in model state dict dot items. Now if I print the, let me print it this way. So first of all, I will print the name with this formatter. Let me yeah, 60 enough. Now I will be printing the value. Okay, now let me execute this code. Yeah, so okay, you can see the all the values and their names, but I don't want values, rather I can call the shape of each. Yeah, so you can see this is how you can get into the actual arguments and their names and then their shapes. Okay, we will explore the layer embeddings class, and within this embedding class you can see we have word embedding, position embedding, layer norm, and then this dropout. So if you notice, we have these values like this word embeddings, then its weights and the shape of this. Okay, so these are the real names of the arguments in the model. Okay, so you can see the position embedding, you can see the layer norm, you can see the layer norm bias. Okay, and yeah, now if you look into this transformer, here we have this, you can see the q linear, k linear, v linear, out linear. So all of these values you can see right here. Okay, with at layer 0 you can see we have 6 layers, so starting with 0th layer, so attention, then q linear and its weights, q linear, its bias, same for k, v, out, and then layer norm. Okay, and it then goes to the as a layer norm and feed forward linear 1, linear 2. So if I show you, these are the feed forward, linear 1, linear 2. Okay, so you can see them right here. Okay, feed forward. Yeah, then yeah, the output layer norm. Now if you notice, we have this layer 1, so it means the next transformer block. Okay, then it goes for all of the remaining blocks till 5, and finally it prints the pre-classifier. Okay, and its weights and biases. Okay, weights and biases. Okay, so that is how you can find the real name of the arguments and their shapes. Now coming to the next part, that is how actually is it computed. Okay, so it is now very important to understand, because when we print the model, we only get the registered modules and submodules. Okay, and with this dictionary we only get the real arguments names. Okay, I'm gonna clear this selected output. Okay, so and this one as well, or I can just keep it. Okay, now what happens when we just print the model, we do not see the forward block, okay, like in which sequence these layers are executed, okay. So you can initiate, or you can define these arguments in the constructor init function that inside the class in any order, but you can use it in any order in the forward class. So we are now going to find how we can look into the forward method of each module, and how we can also look into the init method of each module, okay. To start with this, let me just print the let's say model type. It will give me the class, and inside it, if I just call the module, and it will give me, okay, so this gives me the path to the source code, okay, where it is actually implemented. So if I just simply say from this input DistilBERT for sequence classification, okay, and I just execute this, okay, so I get it, okay. Now let me import the inspect, okay, and this inspect now will have the I will just print the inspect dot get source model classification, okay. Yeah, so it's working. I'll just simply call its init, okay, and let me execute this code and let's see if it works. Yes, it's working, okay. So that is how, like, you simply call this module on each class. It will give you the real source implementation of that class, and then you can get the real implementation of that class, okay. So with this init, I can see the init function or init method of this class. So this is the constructor, okay. So you can see here we have the super, then this number of labels, okay. So here you can see this DistilBERT pre-classifier, classifier, dropout, okay. And if I want to see its forward class, okay, so I can just simply call this maybe forward like this, yes, and it will show you the forward class, okay. So it's a bit messy. Let me just see if embeddings are there. Yes, embeddings is a bit simple class. Let me just show it to you, and here I will just be calling embeddings dot uh, forward, and it will just simply give me what's wrong, okay. So embedding dot embeddings, okay, I did not execute this line, so I can just call this now, okay, and it will give me, okay. So this is the forward function of the embedding class, okay. We will implement this complete code, don't worry, just showing you how we can understand, or how we can get into the real implementation and the flow. Basically these layers are executing in which flow, we want to understand that first. So here you can see this is the forward class, the real code, okay, no guessing over here. So we can now see these input IDs calculation, then the position IDs, and then the embedding, where we are basically combining the position and input embeddings and returning the final embedding, okay. So similarly, if you just simply call this init okay, and execute it. So you can see here we have word embeddings, position embedding, layer normalization, and the dropout. Okay, so this is how you can get into the real code. Okay, now the final question is, okay, so here if you look into this, you can see this config max position, config vocab size, config dimension, each and everything. Okay, just come here and print the model.config and execute it. Okay, so you can see the model.config will give you these values. Okay, so these are the values. We just call them like config.dimension and we get these dimensions. So while implementing our code, if we see something like config dot something like maximum position, and we do not get that value, basically, so we can then uh, call this config dot that variable name and we will get the real value. Okay, so that is how you can like understand the overall architecture. You can explore it. So it almost works for every kind of model then, and specifically this one, if you are doing this part, it will give you the real code architecture. You can look into the GitHub repo of this code as well, but I just want to explore it right here. So everything is right here. Okay, the architecture, then the flow, then the real values, names, and their shapes, everything I just want to see right here, so I don't have to switch to the code and look into that complex code. Okay, so this will give you the overview and the detailed source code as well, so all in one notebook. Okay, now with this we have come to the end of this video, and from next video we are going to start building our model, and in next video we will be building our first code for our first class, and that is embedding layer. So we'll start with the embedding layer. Okay, so that is all for today's video, and I see you in the next video. Till then, bye bye.